Hello students, welcome to my channel GVS Chem. In this video, I am going to explain organic conversions with certain schemes. After these schemes are over, we discuss some conversions also. Please subscribe to my channel, like, share and comment my videos. Now let us discuss organic conversions. This organic conversions is very important question in board examination. Two conversions will be given for 3 marks. To learn conversions, first of all we have to learn reagents. Which reagent gives what reaction? So first of all, organic conversions. So in organic conversions, reagents. So let us discuss these reagents and conversions in different units, that is schemes. So scheme 1. In this scheme 1, let us see the reagent aqueous KOH. Aqueous KOH. Aqueous KOH means potassium hydroxide is dissolved in water, therefore it is aqueous KOH. So what is the role of this aqueous KOH? See here, this is CH2H. So aqueous KOH, CH2, CH3, this is Cl. That is a halogen. Halogen may be chlorine, bromine, etc. So this is in the presence of aqueous KOH. This chlorine is replaced by OH. Chlorine is replaced by OH. Therefore, what do we get? This is CH3, CH2OH. So this is ethanol. This is ethanol. Right. Now, let us take one more reagent. Alcoholic KOH. Alcoholic KOH. Alcoholic KOH means KOH is put in alcohol. Therefore, we get alcoholic KOH. So, in the presence of alcoholic KOH, this is CH2 hydrogen, CH2 bromine. What is this? Ethyl bromide. So, in the presence of alcoholic KOH, what happens is hydrogen bromide is removed. Therefore, we call it as dehydrohalogenation. Dehydrohalogenation. So when it is removed, what happens? This bond becomes a double bond, CH2CH. So we get alkene. So when ethyl alkyl halides are subjected to alcoholic KOH, we get dehydrohalogenation takes place, and of course we get an alkene. So this is in the presence of aqueous KOH, we get alcohol. In the presence of alcoholic KOH, we get alkyl halides become unsaturated alkenes. Now in scheme 1, let us take another reagent, that is addition of hydrogen halide. Addition of hydrogen halide, let us take X halogen atom, let us take bromine. Addition of bromine to alkene. We have two rules here. One is Markovnikov's rule. Another one is anti-Markovnikov's rule, or this is a Karash effect. Karash effect or peroxide effect. We can call it as a peroxide also. Peroxide effect. Now let us see. Let us add hydrogen bromide to an alkene. So here CH3 CH double bond CH2. So this is alkene. This alkene is propene. When hydrogen bromide is added to it, then what happens? According to the Markovnikov's rule, negative part of the addendum, that is bromine attacks to the carbon having less number of carbon atoms. That is Markovnikov's rule. According to Markovnikov's rule, negative part of the addendum, that is bromine, attacks to the carbon having less number of carbon atoms. That means doubly bonded carbon atom having a less number of carbon atoms, and of course hydrogen is added to carbon with more number of carbon atoms. Therefore, what do we get here? This is CH3 CHBr. This is CH3. This is 2-bromo propane. 2-bromo-propane. Now let us see another one, anti-Markovnikov's rule. This is CH3 CH double bond CH2 plus HBr. HBr in the presence of peroxide like barium peroxide, etc. What is this Karash effect or anti-Markovnikov's rule? So in as per anti-Markovnikov's rule, what happens? The negative part of the addendum, that is bromine, attacks to the carbon with more number of carbon atoms. Therefore, we get here CH3 CH2 CH2Br. Here carbon, doubly bonded carbon atom with more number of hydrogens is this. So to this carbon, bromine is attacked, and doubly bonded carbon atom having less number of carbon atoms takes hydrogen. Therefore, what do we get? This is 1-bromo-propane. 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 Right. Now, based on this, let us do a small question, small problem. So, what is the question? Convert 2-bromo-propane to 1-bromo-propane. 2-bromo-propane to 1-bromo-propane. Right. Now, first of all, write the reactant molecule. 2-bromo-propane means this is CH3, CHBr, CH3. So this is the reactant molecule. What is the product? CH3, CH2, CH2Br. This is 1-bromo-propane. Now, what we do here? Just now we discussed some reagents. This is a haloalkane. Haloalkane in the presence of alcoholic KOH. Alcoholic KOH. What happens? Dehydrohalogenation takes place. So here, this is one bromine, and of course from here one hydrogen. Therefore we get CH3, CH double bond CH2. This is propene. This is propene we get. Right. Now this propene is subjected to again HBr. We removed HBr, minus HBr here. HBr is removed and HBr is added. Then what is the difference? See here, HBr is added in the presence of peroxide. In the presence of peroxide. When it is added in the peroxide, what happens? This is in these two doubly bonded carbon atoms, the carbon with more number of hydrogen atoms, bromine, that is negative part, is added. Carbon with less number of hydrogen atoms, hydrogen is added. Therefore, we get this is 2-bromo. This is 1-bromo-propane. 1-bromo-propane. So it's a very simple conversion. Right. Similarly, let us take one more. Here, this is propene to propan 1-ol. Propene to propan 1-ol. What is propene? Propene is CH3, CH double bond CH2. This is propene. What happens here? OH should be added. This is the product is CH3, CH2, CH2OH. That is hydroxy group should be added. Hydroxy group should be added on the carbon, doubly bonded carbon atom with more number of hydrogens, and hydrogen added on the carbon with less number of carbon atoms. Therefore, what we have to do here, water should be added, water. And of course, since the first carbon has to get OH, that is negative part of the addendum. Therefore, here, what happens? This is nothing but Karash effect. That means peroxide should be used. Peroxide should be used. So, if peroxide is used, OH is attacked to carbon with more number of hydrogens, and hydrogen is added to carbon with less number of carbons. Therefore, it is simply a single step conversion. Whereas here, 2 steps are involved. So, this is a simple conversion, propene to propan 1-ol. This is propan propan 1 mole, propan to 1 mole. Right. Now let us take one more in this manner. 2 chloropropane. This is a haloalkane. This in the presence of alcoholic KOH. Let us use alcoholic KOH. What happens? We get CH3, CH double bond CH2. This is alkene, that is propene. This in the presence of water and of course Karash effect. Karash effect. If we use Karash effect, that is peroxide is used. CH3, CH2, CH2OH. So this is a propan 1 mole. Right. So in a scheme 1, we used aqueous KOH and alcoholic KOH, and of course Markovnikov's rule and anti-Markovnikov's rule. Now let us see scheme 2. Scheme 2. In scheme 2, let us make oxidation and reduction. Oxidation and reduction. Right. To work out on oxidation and reduction, first of all we have to understand, we have to know what are oxidizing agents and what are reducing agents. Oxidizing agents are KMnO4 acidified permanganate. KMnO4 oblique H plus means acidified permanganate. Right. K2Cr2O7, this is H plus. And of course in the presence of alkali also they act as oxidizing agents. Now HNO3 nitric acid, CrO3 chromium oxide, and copper in the presence of high temperature 575. So copper in the presence of 575 Kelvin, alcohols, primary alcohols convert into aldehydes and secondary alcohols convert into ketones. So all these are oxidizing agents. On the other hand, reducing agents are lithium aluminum hydride, very strong and expensive reducing agent. Sodium borohydride, NaBH4. So this is hydrogen in the presence of nickel catalyst, palladium and platinum. This is also reducing. Right. Then sodium in the presence of alcohol, C2H5OH. So all these are reducing agents. So oxidizing agents and reducing agents. Now let us see what is a scheme. How do we carry out these reactions? Let us see how do we carry out these reactions. In this, alcohol, aldehyde and acid. Acid means carboxylic acid. So here this is oxidizing agent, and of course from aldehyde to acid, here also oxidizing agent. Any oxidizing agent you can use. And then from carboxylic acid can be converted into aldehyde. Here this is reducing agent, and aldehyde can be converted into alcohol. Here also reducing agent. So if we use oxidizing agent, alcohol converts into aldehyde and aldehyde converts into carboxylic acid. Similarly, if we use reducing agents, carboxylic acid converts into aldehyde and aldehyde converts into alcohol. Now let us see different conversions here. CH3, CH2OH. This in the presence of copper and 575K. So what do we get here? CH3CHO. This is ethanol. This is acetaldehyde. Ethanol, acetaldehyde. What are the other oxidizing agents? CrO3. So this is ethanol, CrO3. We get CH3CHO. Right. Now if we use KMnO4, acidified permanganate, we get aldehyde, CH3CHO. Permanganate and dichromate, they are very strong oxidizing agents. Therefore, they do not stop the reaction at aldehyde stage. So, they further act. These strong oxidizing agents further act and directly what happens? Aldehyde changes to acid. Therefore, this is CH3COOH. So, you can keep your acidified permanganate, or even you can use dichromate also, or nitric acid also. So, acidified permanganate, dichromate, nitric acid, etc. they are very strong oxidizing agents. So, in the presence of strong oxidizing agents, alcohol converts into aldehyde. The reaction does not stop at the aldehyde stage, and it goes to next step, that is converts into acid. So, these are some examples of oxidation. Now, using reducing agents. Reducing agents. Let us take lithium aluminum hydride. So, CH3COOH. When we take lithium aluminum hydride is very strong reducing agent. LiAlH4, we get it reduces to aldehyde. Acid reduces to aldehyde. That means here 2 oxygen atoms are there, only 1 oxygen atom is there. So, number of oxygen atoms are decreased. Therefore, acid is reduced to aldehyde. Now, this is again lithium aluminum hydride. Therefore, we get CH3CH2OH. What happens here? Hydrogen is added. Therefore, this is ethanol. So, as LiAlOH is a strong reducing agent, the reaction, both the steps take place one after the other. Right. Now, if sodium borohydride is used, sodium borohydride is not a strong reducing agent. Therefore, we get CH3CHO. The reaction stops here. Right. If we continue this reaction, we get acid. Whereas here, if we take acid, we do not get aldehyde. Directly we get alcohol. Here we get aldehyde also. Right. Now, other reducing agents. This in the presence of hydrogen in the presence of nickel. Therefore, we get CH3CHO. So, in this way, we can carry out oxidation and reduction in scheme 2. Now, let us take a typical conversion. Propanoic acid to ethanoic acid. Propanoic acid to ethanoic acid. This is CH3CH2COOH. This is CH3COOH. So, one carbon, parent substance, reactant has 3 carbons, whereas product has only 2 carbons. That means we have to reduce 1 carbon. Now, how do we carry out this reaction? So, whatever in the scheme 1 and scheme 2, whatever we learned, we have to use. Apart from that, we use some named reactions also, which we discussed already in the previous videos. So, this is CH3CH2COOH reacts with sodium. Therefore, what do we get? CH3CH2COONA. Now, this is made to react with soda lime, NaOH, in the presence of calcium oxide. Then what happens? We remove carbon dioxide. This is soda lime decarboxylation. Soda lime decarboxylation. So, when soda lime decarboxylation takes place, what do we get here? CH3CH3. Now, this is treated with chlorine in the presence of sunlight. Therefore, we get CH3CH2Cl. Right. This haloalkane is treated with aqueous KOH. When it is treated with aqueous KOH, halogen atom is replaced by OH group. Therefore, we get CH3CH2OH. Now, this alcohol is oxidized to acid. If we use lithium aluminum hydride directly, what happens? Alcohol converts into alcohol oxidizes to COOH, acetic acid. So, alcohol oxidizes to acetic acid. So, this is a typical example of a conversion of propanoic acid to ethanoic acid, where the one carbon is less in the product compound. Now let us convert ethanoic acid into ethanoic acid to propanoic acid. Ethanoic acid to propanoic acid. What is ethanoic acid? CH3COOH. Propanoic acid CH3CH2COOH. So in the previous conversion, propanoic acid is converted to ethanoic acid, that is one carbon becomes less in the end product. Whereas the reactant has only 2 carbon atoms and product has 3 carbon atoms. That means one carbon becomes more. So here in this case, CH3COOH in the presence of lithium aluminum hydride. Therefore, what do we get? This is CH2OH. Now this is treated with thionyl chloride, SOCl2. This is thionyl chloride. Thionyl chloride. If it is treated with thionyl chloride, the OH is replaced by Cl. Therefore, this is CH3CH2Cl. This on treatment with potassium cyanide. So chlorine nucleophile is replaced by Cn nucleophile. Therefore, we get CH3CH2Cn. This is propane nitrile. Propane nitrile. When propane nitrile is hydrolyzed completely, H3O plus, complete hydrolysis. When it is complete hydrolysis, what happens? This Cn becomes COOH. Therefore, this is CH3CH2COOH. So in this way, we can convert acetic acid into propanoic acid. That is, one carbon becomes more. Now let us discuss scheme 3. In scheme 3, carbonyl compounds are treated with hydrogen cyanide. Carbonyl compounds are treated with hydrogen cyanide. Strictly speaking, hydrogen cyanide is obtained, HCN is obtained by reacting sodium cyanide with HCl. When sodium cyanide reacts with HCl, we get the hydrogen cyanide. Right. Now, let us add this CH3, C double bond OH. What is this? Acetaldehyde. This is acetaldehyde plus HCN. So here in the HCN, hydrogen has a plus sign and partially positive charge, and Cn, cyanide, has partially negative charge. So this bond shifts here. Therefore, this hydrogen attacks here and this cyanide attacks here. Therefore, what do we get here? This is CH3, COH, Cn. This is hydrogen. What is this? Cyanohydrin. If same OH group, hydroxy group and cyanide group is present on the same carbon atom, this we call it as a cyanohydrin. Cyanohydrins are very important class of substances for the preparation of many other substances. So this is since it is obtained from acetaldehyde, this is known as acetaldehyde cyanohydrin. Right. Now this is treated with hydrolysis, complete hydrolysis. What do we get here? This is CH3 HOH. This is COOH. What is this? Common name of this substance is lactic acid, or otherwise 2-hydroxypropanoic acid. Now this is treated with dehydration. Dehydration takes place in the presence of a concentrated sulfuric acid. So OH from this carbon and one hydrogen from this carbon is removed as water, minus water. Therefore, what do we get here? This is CH3, CH2, this is CH2, double bond CH, COOH. COOH. So what is the name of this substance? Acrylic acid. Acrylic acid. So from cyanohydrin we got lactic acid and of course acrylic acid. If it is treated with, this cyanohydrin is treated with lithium aluminum hydride, what do we get? This is CH3COH, hydrogen here. This is CH2NH2. CH2NH2. Amine is formed. Amine, right? This amine again subjected to another changes. When this amine is treated with acetyl chloride, CH3COCl, what do we get here? This is CH3CH, this is OH, this is CH2NH, COCH3. COCH3. So this is a complex substance. The name of this complex substance, this is amide. This amide group is main substance on amine N, on nitrogen atom all this group is present. Therefore we give the name accordingly. So from this cyanohydrin, see how many substances we got. Now let us see scheme 4. Scheme 4. Let us take phenol here. This is phenol OH. Phenol is treated with zinc dust. So at high temperature. This is distillation. Distillation under high temperature. What happens when phenol is subjected to distillation under high temperature with zinc? We get benzene. Benzene. Plus of course zinc oxide is formed. This zinc oxide, right? Now the so formed phenol is subjected to electrophilic substitution. Electrophilic substitution. Electrophilic substitution. So different variety of electrophilic substitutions are there. One is chlorine in the presence of FeCl3. Therefore we get chlorobenzene. Bromine in the presence of FeBr3. Therefore we get bromobenzene. In the presence of KCN, potassium cyanide, we get cyanobenzene. In the presence of nitric acid and concentrated, this is HNO3. In the presence of H2SO4, we get nitrobenzene. In the presence of concentrated sulfuric acid, we get OSO3H. This is benzene sulfonic acid. This is nitrobenzene. This is cyanobenzene. Right. Now, in Friedel-Crafts alkylation, CH3Cl in the presence of AlCl3. What do we get here? This is CH3 is added. This is toluene. TOLUNE, toluene. Right. Now in the presence of, suppose if we take CH3COCl, acyl chloride. Therefore what do we get? This is COCH3. What is this substance? Acetophenone. If we add C6H5 COCl, then what do we get here? This is already one benzene ring and C double bond O. This is benzophenone. So in this scheme 4, we get a variety of substances due to the electrophilic substitution on benzene ring. Benzene is obtained from phenol. Suppose if the conversion is asked, convert phenol to say toluene. So what happens in the first step? We have to convert phenol into benzene by treating with zinc dust. Right. Then the so formed benzene is treated with methyl chloride in the presence of aluminum chloride, anhydrous aluminum chloride. Therefore we get toluene. In the next video, let us discuss some more schemes involving conversions, organic conversions.